Now chloralkali process, it is chlor. So the word chlor means chlorine. Alkali, basically any basic solution which is water soluble. So normally in alkali we take the sodium hydroxide. So chloralkali process, it is the process used to prepare sodium hydroxide and chlorine is obtained as byproduct. So in this we take NaCl aqueous and it is called as brine. Sodium chloride aqueous solution which is impure is called as brine. And when it is subjected to undergo electrolysis, means that current is passed through it. So on passing current, there will be electrolysis, and here there will be NaOH aqueous plus hydrogen. So these two will be around cathode and plus Cl2. So this is gas, this is gas. So this Cl2 will be around. So this is the reaction. This is the reaction in one step. But actually reaction takes place in some different way. Like how it proceeds, NaCl aqueous. So first of all, it breaks from the sodium ion plus Cl. This is the first reaction. NaCl breaks, NaCl is split into Na ion, sodium and chloride ion. Then at anode, what happens? Anode is positive. So what happens? At anode, negative particles will go. The negative is chloride ion. So two chloride ions will go, and at anode there is always oxidation. What is oxidation? Loss of electrons. So there will be Cl2. So chlorine gas is obtained at anode. That's why I've written. So electron has been lost. Loss of electron is called as oxidation. Now coming to cathode. So cathode is negative. So negative, positive ions will go. So Na plus electron, and then version of Na solid. So this is there. Now this is first reaction. This is second. This is third. Now what happens? The sodium is produced. Sodium is liberated. Sodium is deposited at the this cathode. Sodium is deposited at cathode, and so this solution is in water. So what happens when sodium comes in contact with water? It catches fire. However, see, the reaction is very slow. Very small amount of sodium is formed deposited at the cathode. So this reaction, sodium solid, this sodium solution will be consumed here, and H2O will be NaOH aqueous plus hydrogen. So this is the co-reaction. This is the co-reaction how the chloralkali process is. So this is the chloralkali process. Now I'm going to explain a very important part, that is plaster of Paris. So plaster of Paris is obtained by gypsum, CaSO4 2H2O. Commonly it is called as gypsum. Gypsum is common name and scientific name is calcium sulfate dihydrate. Di means two. So two water molecules are present. And on heating at 373 Kelvin. On heating at 373 Kelvin, so there is a solution of CaSO4 half H2O plus 1.5 H2O. So this is plaster of Paris. Now it is called as calcium sulfate hemihydrate. Its scientific name is calcium sulfate semihydrate. Semi means half. So it is semihydrate or hemihydrate. So temperature is very specific. 373 Kelvin is the temperature. And if temperature is increased, then it loses water molecules completely. And the formation of dead burned plaster. So I am going to explain next dead burned plaster. Dead burned plaster. So when CaSO4 half H2O, so just I am writing here to balance it. And so it is heated above 373 Kelvin. So it loses water molecules completely. And so this is anhydrous. This is anhydrous calcium sulfate. Anhydrous calcium sulfate. Yes, sir. अभी तो हाँ सर उसका कभी नहीं हो रहा था 2 साल 7 दिन के होंगे वैसे कभी नहीं खराब से अगले साल में क्लास चलेगा So this is the dead burned plaster. Now this dead burned plaster, it is called so because this dead burned plaster is called so because there is the loss in the properties. There is the loss in the property of plaster of Paris, and this plaster of Paris cannot set into hard mass. It cannot set into hard mass once again by mixing little amount of water. So that's why it is called as dead burned plaster. So they say anhydrous calcium sulfate. It is called as dead burned plaster. It is called as dead burned plaster. Dead means which has died. So it is because of heating at about 373 Kelvin. It loses water molecules completely, and it can never set into hard mass, and so it is called as dead burnt plaster. Now this plaster of Paris is very much important, and so plaster of Paris, when it comes in contact with little amount of water, it sets into hard mass, little amount of water, like this. CaSO4 half H2O. This is plaster of Paris plus little amount of water, just moisture. So CaSO4 2H2O. So this is the formation of gypsum. Now I'm going to explain about the extraction of metal. So this is having the following points. First is preliminary treatment. Preliminary treatment. Second is reduction of concentrated ores into metals. This is the second part. And third is refining of impure metal into pure metal. So these are the three basic parts. And in preliminary treatment, just I am going to brief you. In preliminary treatment, the ores are concentrated by removing the impurities. Impurities are removed by a suitable method. It can be physical method, it can be chemical method. So preliminary treatment involves the removal of impurities by the suitable methods. It can be by hydraulic washing, as you know, or by gravity separation, or by any suitable method, depending on the nature and type of impurities. So this is the preliminary treatment. Then coming to reduction. So reduction of concentrated ores. So ores are concentrated by preliminary treatment, and when ores are concentrated, ores are then subjected to heated under the proper condition. Proper condition means proper reducing agent. Reducing agent is important. So let this be Fe2O3 iron oxide. This is ore of iron. Then here it is carbon monoxide. It is used as reducing agent. And then Fe plus CO. So this is the equation for iron. Now there is a change. Metals are of three types. More active metals like sodium, potassium, lithium, they are very active metals. So they can be accepted by other metals. So this is the medium reactivity. Medium reactive metal. Now more reactivity. More active metals like sodium, lithium, potassium, calcium, etc. They are extracted. They are extracted by the electrolysis of molten salt. Molten salt. Let it be, NaCl, molten, and current is fast, and so this sodium solid plus chlorine gas. So it is in case of more active metals. So lithium, sodium, potassium, calcium. So these metals are at the top of the periodic table, above the group. Now coming to least active metals. Least active metals like silver, gold, etc. So these metals are obtained mostly from the their soil or the sand found in nature, or they can be obtained by use of reactive metals. So like mercury sulfide. There are different examples. HGS. Mercury is least active metal. So this is ore of mercury. It is cinnabar. Cinnabar. This is in presence of oxygen or air. Roasting Fg plus. So there are different ways to extract metals from the different ores in different categories. ठीक है बेटा, समझ आ गया?
Yes, sir.
Yes, sir.